Hello everyone, hope you all are doing great. My name is Nanda Kishore. Regarding Sparks Foundation, the task number 2 prediction using unsupervised machine learning. To perform this, I used Python platform and the version 3.8. I used Jupyter Notebook here as an environment, and I will try to complete this video within 10 minutes itself. The dataset, it is an IRIS dataset. We try to clustering our dataset by using K-means clustering. The dataset consists of a sepal length, sepal width, petal length, and petal width. These are the features, and final class is already given here. That is groups. That is based on these flowers sizes. The class is already divided here. You can see here iris flower how it looks like. That is this is an iris flower. This is already petal and sepals is already labeled here, and based on sepal sizes and petal sizes, petal width and petal length, based on these size of information, we divided the groups. That is, three groups are already given, which is given in the data sets also, but we will predict but all this information how many cluster we can divide, and also we can, after building our model, we can compare them by actual and predicted. We can see the homogeneity between the actual and predicted also. For this, I use mainly in basic libraries, that is pandas, numpy, cborn and matplotlib. To load the dataset, I used pandas. By using pandas, I loaded the dataset, and later on we can see the first five and last five records. By I appended here in the I appended tile in the head itself, so we can see the first five and last five here. The sepal length, sepal width and petal length, these are the sizes. Based on these sizes, final species is already given here, that is which is iris sectosa or virginica or versicolor. So the data set, the shape of the data set is 150 and 6 columns, 152 and 6 columns. And if you see the data information, that is uh, all are non 150 non null values are present here. All are same. So total data set is 150. We can say that 150 non null values. It means though there is no null value here, and id is int, remaining all are float, and species, that is it is in object. And we don't need require that id column, so id column we can remove that id also. Let's see that the data species, how many actually species are present in data sets itself. We can see that the unique species, that is three species are present here. And let's describe the data set. We describe the data set. It gives the whole description of data set, that is mean, count, minimum, maximum. And let's drop the id column, that is which is not necessary for us. We can see the some duplicates values. This duplicate values, we can't consider it is as a duplicate value because it is a flower data set. Maybe some flowers can be with a similar sizes, so we can't consider that is we can't consider it is an a duplicate value. So I didn't remove this. I tried to next some exploratory data analysis, so that I tried to do some exploratory data analysis. Here I used only cborn because cborn is built on top of matplotlib. So simply we can give a beautiful handsome plots we can draw here by using a cborn itself, by using a colors, different colors with a simple code. So I use this, I prefer mainly for cborn itself. So I try to draw a scatter plot by using sepal length and petal length. By by seeing here itself, we can say that there is a three groups here. Blue, we can see that the three blue color is present here. All the blue color belongs to one group, and orange color all belongs to one group, and green color belongs to one group. We can say here by itself also itself. And let's see, by using model k-means clustering, we can say how many groups we can form better than this. So in the similar fashion, I draw different scatter plots, and here we can see the box plot by using sepal length. We can say that if the sepal length is between 4 to and 6, then we can call it is an iris setosa. If the sepal length is between the 5 to and 7 by 5 to 7.5, then we can call it is a sepal length. In the same manner, I created one more box plot using a sepal width. It is a volume plot between sepal length. If the length is between the 1 to 2, then it is iris rectosa, and between the 3 to 5, then it is a iris versicolor. In the same manner, I plotted one more volume plot. Next, I did the data pre-processing by using a min-max scaler, because all values are not in one range. Some are in 9.9 centimeters, some are in 1 centimeters. So it is not. I feel it is won't give us some better homogeneity or better accuracy results. So I tried to do pre-processing. So all scaling is done. I did here. Later on, I imported from sklearn.cluster import a KMeans. I imported the KMeans to find the number of to find the number of clusters, that is K value, how many groups we can from. For that, I took a elbow method. For this, I run a for loop here from 1 to 10 range. Then I draw a one elbow method. After the elbow method, there is a huge error here. If you take one cluster, then if you take two clusters, then it will error is also some more. From three, if you take three clusters, it is the optimal value. So we can say that is an optimal, because error is reducing here, started reducing here. So optimal value we can take the only three clusters. So the model will take only 1D array. So I take only values here. So I fitted the model and I predicted. While I am fitting the model, I took given only three clusters here, but we have seen elbow method. So 0th cluster, first cluster, and second cluster, three clusters. Later on, I have tried to see the centroids. Human eye can support only the two dimensionals. So based on the sepal length and petal length, if you see from the sepal length in x-axis and petal length in y-axis, then the centroid is present in the 0th cluster. It is here. Red color is clusters. In the same manner, I found that one more between the sepal width and petal width, the clusters are present in the 0th cluster, and first yellow green color is second cluster, third is different number 2 cluster. In the same way I did 4 plots here. Finally we can see the difference between what we predicted and actually what the dataset have. The dataset consists of a 3 iris sectors, iris versicolor. We are also labeled that same way in the iris versicolor, sectors, and virginica. So we will see the homogeneity between actual and predicted. Then here we can see that the 74% of homogeneity we got, that is 75% of homogeneity between the actual and predicted. Then we can see here between the actual and predicted. This is the actual data set, that is what given what we have, that iris sectosa, virginica, versicolor. Here we have that the say what we predicted here on right side, that is we can say here blue color iris, iris virginica, it is mostly we have predicted exactly correct. And green color, we can say that some are misclassified here. So here maybe we got a less accuracy because of this. We can go, maybe we got a less homogeneity. Whatever it is, by seeing itself, we got three optimal value, k value is 3. So three clusters is the good for this. And we can conclude here by seeing by visualization itself, we can say that the three clusters can from